All right, CNT125, Chapter 8. We're moving through our section on subnets, and I'm going to give us some subnetting fundamentals, almost like some background rules for subnetting before we even tackle subnetting. So here's a couple things we want to remember or get kind of in line. First, let's remember the network address or network ID. This is the number that identifies your network, like Main Street, Mechanicsburg, PA, as opposed to Main Street in Dayton, Ohio. On a network, the host portion, when it's all zeros, is identifying the network. So a 95000 would identify that network. A 135.50.00 is going to identify that Class B network. 195.32.12.0 is going to identify that Class C network. Again, why is this important? It identifies the network. It's like putting up a street sign. Why also is important? We cannot assign that number to anything. Just like I can't have a house assigned 0 Main Street Mechanicsburg, PA. That is not done. That is normally not done. So the same thing on my network. I can't assign 195.32.12.0 to a printer on my network. We would have trouble printing to it. Okay, so that's your network number. Remember your network number. The other end of the stream, we need to remember our broadcast address. Remember when we have all ones in the host portion, 255 typically, that is a broadcast number that can get used to send a message to everybody on that network. I might send a note out, a message out to say, hey, does anybody know this address? That'd be a broadcast. That is going to hopefully just go to my network then. So a broadcast address, when we have all ones, or 255, not always 255, but usually 255. If I have the host portion as all ones, that's a broadcast message. 95, 255, 255, 255 would be a broadcast for that Class A network. 135.50, 255, 255 would be a broadcast for that Class B network. 195.32.12, 255 would be broadcast for that Class C network. Again, why is that important? It's a number that gets used to send a message to everybody on the network. Secondly, I cannot assign that to a node on the network. I can't assign that to a printer. If I tried to print to that every time I went to print, that message would go to everybody on the network, which I don't want to do. So the network ID or network address, I need to remember host portion is all zeros. I can't use that to assign to a computer or printer kind of thing. Broadcast address, host portion is all ones. A lot of times I'll see that as 255. Again, I can't assign that to a computer, printer type of thing on my network. I can, however, assign a host address. When I have a combination of ones and zeros in the host portion, that is now a node or usable host address. That'd be something like 123 Main Street, Mechanicsburg, PA, 124 Main Street, Mechanicsburg, PA. Again, the host portion is not all zeros and it's not all ones. So an address like 95, 25, 515, that would be a valid host address for that Class A network. 135.50.25.5 would be a valid host for that Class B network. 195.52.12.5 would be a valid host address for that Class C network. That is a number we can actually use to assign to a computer, a printer, a server, an access point, etc. All right? Next thing we want to remember is subnetting is really just taking the whole network and breaking it into equal pieces. Kind of like cutting a large pizza into 4 pieces or 8 pieces. I'm going to take that large pizza and break it into equal pieces so everybody can have a piece and, all be happy, as opposed to one person having the whole pizza and nobody else having any pizza. So subnetting is that same concept. I'm going to take the big network and I'm going to break it into equal pieces. So if I had numbers ranging from 0 to 100 and I needed 4 equal pieces, I would go 0 to 24, 25 to 49, 50 to 74, 75 to 100, and I get, bada bing, bada boom, 4 equal pieces of 25. Okay, yeah, we start with 0. 0 is a number. So if I were dealing with 0 to 100, this would be pretty easy. 10 equal pieces, 0 to 9, 10 to 19, and so forth. Okay, easy peasy. Unfortunately, we're working with 0 to 255, so the numbers look a little funnier. But it's the same idea. If I need 4 equal subnets, or 4 subnets. I make them 4 equal pieces here. 0 to 63, 64 to 127, 128 to 191, 192 to 255 is 4 equal pieces of 0 to 255. I just took my pizza and cut it into 4 pieces. I just took my big network and I cut it into 4 small pieces. That is all subnetting is. It's just a little messy because we're dealing with a 0 to 255. That's where the messy part comes in. So to do this, I'm going to take some bits from my host portion and turn them into a subnet piece. So if I have a subnet mask 255.0.0.0, if the subnet mask becomes 224.0.0, I took a couple bits from this octet to make it a subnet piece is what I did. And this now becomes the subnet, network and subnet part over here, 255.224, and then the remaining zeros here and here become the host piece. That's all we're doing. If my subnet mask is 255.255.0 class B, if I take a couple bits from this octet, that now becomes my subnet piece. If I'm dealing with a class C, 255.255.255.0, I could borrow 1 or 2 from this last octet to make it a subnet piece. That's all we're doing. And that helps us figure out these equal pieces. Taking the pizza and dividing it into equal pieces. That's what it's doing for us. So to do that, I have 2 rules. One is I'm always going to borrow bits from left to right. The second one is I must leave at least 2 bits. Alright, so let's tackle the first one first. Borrow bits from left to right. So if I have a Class A network, 125.0.0.0, subnet mask is 255.0.0.0, my host portion is these 24 bits right here. Let me get them highlighted. That's my host portion, these 3 octets, 0, 0, 0. There's my 24 bits. Well, I can start borrowing bits here, and I can borrow as many as I need. We'll figure that out later, how many we need. We'll figure that out later. But I would borrow from here left to right to make my subnet piece. So I might do this. I might borrow the force 4 right here to make my subnet piece. And when I do, I just take this number right here, convert it into decimal, bada bing, bada boom. There's my 240. 240 and this right here are the same. Okay, this is why we learned your binary conversion back in 120. That's why we did that, to help us now. Let's take a look at another example. Let's say we have a Class B, 155.55.0.0. My default subnet mask, 255.255.0.0. Here's my host piece. There's my 16 bits of host piece. I can start borrowing bits from here, going right. So if I want to, I can borrow 3 bits to make a subnet piece. Again, we'll figure out how to calculate the number of bits borrowed in a minute here, so hang in there. So if I do that, borrow 3 bits, this right here, when I convert it to decimal, I get 224. That's what that number is, 224, and that right there are the same number. And if I take a 220 network, we see it's a Class C, default subnet mask 255.255.255.0. Here's my host bits, these 8 bits right there. Again, I can start borrowing from there, going to the right. So if I borrow the first 2 bits to make subnet, right there, there's the first 2 bits, that'll be my subnet piece. If I take this decimal number and if I take this binary number, convert to decimal, I get 192. And I'm just adding up those place values, 128 and 64, and I get 192. Okay. Actually, if I go back one, I'm adding these 3 place values, 128, 64, and 32. That's how I got my 224. And if I go back one more, I borrow these 4 bits here, 120, 64, 32, and 16. That's how I get my 240. Okay, just to refresh your memory on those binary conversions. But I'm going to start left to right, and I can borrow as many as I need. We'll figure that out in a minute, but I have to borrow left to right. That's my first rule. The second rule then is I need to leave at least 2 bits behind. And why? Well, I need to make sure I have usable addresses for hosts in the middle, if you will. So if I have a Class C network right here, here's my 255.255.255.0, here's my host portion, there's my 8 bits. If I borrow 6, and I'm going to leave the 2 behind, I'm going to borrow 6 bits for subnet, here's my 2 remaining host bits. That's what the rule says, I have to leave at least 2. Well, if I look at those 2 bits, and I'm going to take them and write them down here, and I write out all the combinations, 0, 0, 0, 1, 1, 0, 1, 1. I literally count it up in binary. 0, 1, 2, 3. Okay, that's what I'm doing right there. Well, if I remember my rules, The 00 would be a network number. All zeros in the host portion would be a network number. That's a network ID. I can't use it. This would be usable 01, 10. Remember, any combination of ones and zeros, that's a usable address. But then the last number down here, 11, all ones in the host portion is a broadcast. Again, that's not usable. So this first address being 00 is the network, I can't use it. This last one being 11 is a broadcast, I can't use it. I only get 2 usable addresses. So when I'm leaving 2 bits behind, I get 2 usable addresses out of it. Which, if I'm dealing with a connection between, Harrisburg router and Gettysburg router, we only need those 2 IP addresses, one for each router. There's nothing else in between that I would need to identify. So for that link between Harrisburg and Gettysburg, this would be fine. That subnet would be okay. But there's the reason I have to leave at least 2 bits. So those 2 rules, making sure, I'll go back here real quick. Here's my 2 rules. Bar left to right always in the host portion, and I need to leave at least 2 bits behind in the host portion. So, a Class A network, I have 24 bits that I can use for subnetting. 24 bits that I can I can use for borrowing as many bits in there as I need to make my subnets. Class B, I have 16 bits available. Class C, I have 8 bits available for doing my subnetting. And again, remembering the left to right. Bar left to right, must leave at least 2 behind. Okay? We come back in the next one, we'll talk about subnet planning. How I figure out the number of bits I need to borrow.